Hi everyone and welcome back to the channel. Today we're diving deep into the engine room of machine learning data preprocessing. We'll walk you through our complete workflow for students' performance dataset, which was a part of our predictive analysis assignment. So our project focuses today on the most foundational and essential process in the analysis lifecycle, data preprocessing for a student's performance dataset. So let me introduce our team members. So we are group 3 and we are team responsible for executing and reporting of this comprehensive data workflow. I am Jovito Francisco Fernando Maya de Aruzu with the matric number 702710, and I'm joined by my colleagues Adil Muhammad Fauzil Mutakin with the matric number 297016, and also my friends Muklis Aminur Hakim Putra with the matric number 702711. And we have worked collaboratively to ensure that highest standard of data preparations, and we are excited to walk you through our methodology and specific findings. So in the slide, introductions to the predictive analytic assignment. So the central goal of this assignment was to perform a complete end-to-end data preprocessing workflow. This is not just about cleaning data, it's about transforming raw, messy input into a gold standard machine learning ready state. So the context for our work is a real-world educational domain dataset focusing on dataset academic performance. This data is rich, contain students' demographic, such as gender and income level, alongside their academic achievements. So this preparation is the critical first step before any predictive modeling can even begin. Our work was executed entirely using Python, leverage the power of the libraries like pandas for data manipulations and scikit-learn from transformation. So this is key variable and preprocessing objective. So we implemented a structured pipeline to ensure data integrity and model performance. So our entire preprocessing effort was focusing on preparing the data to predict two crucial outcomes. So first is total score, like the numeric variable and overall student score, representing the overall student score, predicting this will be a regression task. So the second is grade, like this is categorical variable. As you can see, A, B, and C, and etc. This representing overall academic performance. Predict this will be a classification task. Initial inspections of the dataset show 5,000 records across all core features. We also noted several text-based identifier columns like student ID and email. Our overall pipeline was designed by systematically address 5 main objectives like clean, encode, scale, and reduce the data. So this is data preprocessing methodology. So first we are data loading and initial exploration. First thing that we need to do is we need to upload the dataset. After we upload the dataset, we inspect data types and non-nose values to understand the structure. And after that, data cleaning and missing values. We drop it relevant columns to input a missing categorical with mode, numerical with median. And then after that, we find an outlier detection and removal. We use IQR method to identify and remove extreme values from numerical columns, and then data transformations encoding. So we manually map it ordinal variables, label encoding for numerical categorical features, and then data transformation or scaling, and then after that reducing PCA. So first thing that we use, step 1 is data cleaning. So the missing values detection and imputations. So moving to the cleaning phase, the first step was identifying and handling missing values. We employing a sophisticated imputation strategy tailored to the type of feature. As you can see here, for categorical variables like study hours or parent educations, we inputted with the mode. We choose the mode because it's preserved the frequency of the most common category, which is often better estimate for missing nominal data. And then after that, numerical data, like we inputted missing values with the median. The median is statistically preferred over the mean because it is less susceptible to scaling by potential outliers. So finally, we permanently remove non-predictive columns like student's ID, name, and email, as they are irrelevant noise for predictions. This rigorous cleaning process results in a dataset with zero null values. As you can see in the implementations, we are dropping ID columns div clone in our project in Google Colab.
Okay, so in this part of the preprocessing, we focus on two steps: removing outliers and encoding categorical variables. First, for outlier removal, we use the IQR method. We calculate Q1 and Q3, then filtered out values that were too far outside the normal range. Outliers can affect the accuracy of our prediction, so cleaning them helps stabilize the dataset. After this process, the data went from 5,000 to 4,996 rows. This means we remove only a few extreme values while keeping almost all the information. Next, we handle categorical encoding because machine learning models cannot understand text, so we converted all categorical values into numbers. For features that have a natural order, like income level or parent education, we use ordinal mapping. For variables without order, such as gender, we applied label encoding. After this step, all categorical fields were fully numeric and ready for further analysis. Next, we standardize all numerical features using standard scalar. This step adjusts the value so they have a mean close to 0 and standard deviation close to 1. Standardization is important because some algorithms are sensitive to differences in scale, and without it, larger values might dominate the model. By scaling the features, we make sure each variable contributes more fairly. We also applied principal component analysis, or PCA, to reduce the dimensionality of the dataset. Here we reduce the data into two main components for visualization. The first two components explain around 13% of the variance, which is expected for a complex dataset. Even so, the PCA plot still help us to see the patterns, such as how different grade level tend to form loose clusters. And this also gives us insight into the structure of the data before modeling. Okay, for this slide, this slide compares the descriptive statistic before and after preprocessing. Before cleaning, the data had different range, missing values, and some outliers. And after preprocessing, the standardized data shows consistent scale with mean around 0 and standard deviation around 1. This tells us the data is now cleaner, more balanced, and ready for modeling. And these visuals help show the effect of our preprocessing steps. The histogram, correlation heat map, and PCA scatter plot all give insight into how the data behaves after cleaning and transformation. From these visuals, we can better understand distribution patterns, relationship between features, and potential cluster in the dataset. This helps guide our decision for future modeling. Okay, for this histogram shows the distribution of total score after cleaning. The curve looks smooth and close to a normal distribution. This means the data no longer has extreme outliers, and the scores are more stable. The central tendency is also clear, which is useful when we later build the predictive models.
Okay, so to illustrate the construct result of all this step, this table shows a sample of the process data. Notice the absence of the text data and the comparable range of values across all columns. This is the exact numerical input format required for training any sophisticated machine learning model, ensuring optimal performance and convergence. And with the data now rigorously prepared, we transition into the next phase, predictive modeling. Our processing effort has prepared the data for two distinct types of model. First is classification model model to predict the grade ABC using techniques like logistic regressions, canary snake birds, or decision tree classifier. And the second one is regressions model to predict the continuous total score using a model like linear regressions or advanced sample methods. So the quality of this processing is the guarantee that our future model selections and training will yield accurate, stable, and generalized results. So we want to emphasize the fundamental benefit we gain from investing time in preparation phase. First is data accurately handling missing values and removing noise ensure our data is complete, preventing unexpected error during a model training. Second is robustness. Outlier removal leads to more stable and reliable model training, making the models less sensitive to extreme unusual case. Third is compatibility. Encoding and scaling make the data universally compatible with all required machine learning algorithms. And the fourth is insight. EDA, correlation, and PCA provide immediate visual understanding of the data structures, which will inform our choice of algorithm moving forward. So this is the reflection. Reflection on the assignment, we believe the step with the greatest impact was the combination of missing value handling and outlier removal. Together, these two steps fundamentally improve the dataset completeness and inherent consistency, moving the data closer to its underlying truth. However, we also encountered several challenges. First is the inherent traits of in choosing between the median and mode or imputation, a decision that requires careful domain knowledge. Second is stabilizing the correct boundary for outlier detections, balancing the need to reduce noise against the risk of losing valuable non-erroneous data, and correctly interpreting the low variance explained by the initial PCA component, reminding us that the data complexity often requires more than simple 2D visualization. So, in conclusion, this assignment successfully demonstrates the critical role of the data processing in predictive analytics. A well-processed dataset is the non-negotiable foundations for accurate, stable, and generalizable models. So our final dataset is complete and clean, free of missing values, irrelevant columns, and obvious outliers. And the second, numerical and scale. All features are numerical and standardized with the comparable range. And the third is ready for models. It provides the essential high-quality foundations for any future classification or regression tasks, completing the first major phase of our predictive analysis project. So thank you